Thermochemistry is a physical chemistry that studies the changes in heat in a chemical reaction. The reaction can be endothermic or exothermic. In endothermic reaction, if you want, for example, to melt an ice cube, so heat will be absorbed to the system or to the reaction, so the ice cube melts. The direction of the heat is in the system, in the reaction. So we call it endothermic reaction. Exothermic reaction when heat is released. For example, if you want to freeze a glass of water, if you want to freeze the water, so heat will be released, will go out, exiting the system, so we call it exothermic. In endothermic reaction, delta H or the enthalpy has a positive sign. Exothermic delta H has a negative sign. Now the graphs for both. Endothermic reaction, heat is absorbed. So starting with the reactants, heat is absorbed, the activation energy, then the products. Enthalpy of reactants, enthalpy of products. For exothermic reaction, starting with reactants, releasing energy, so the heat will be finally lower than the reactants. Okay, this amount of heat that is needed to start up the reaction, and we call it the minimum amount of heat to start the reaction, is called activation energy. And the activation energy in exothermic, starting from the reactants to the upper level of the graph. This, the higher level, is called the activated complex, and it is not stable. Whenever heat is increasing, so the reaction is not stable. Examples for two reactions. The first one is decomposition. Decomposition of calcium carbonate. It needs heat, so we add heat to this side plus heat. Whatever amount will be given to you equals the products. So the reactant side with heat and the product side. On the other way, the exothermic reactions basically are the combustion reaction. Combustion means burning with oxygen. So they're going to release heat, like the combustion of methane gas. So heat will be with the product side. Now, I'll give you an example. Example for calculating enthalpy and figure out if it is exothermic or endothermic. In this reaction, the standard enthalpy combustion data for each reactant and products is given to you, and then find out the delta H enthalpy. Delta H is H products minus H reactants. Now the products are only C4H10, delta H is this number, so negative 2877 minus, open a bracket, hydrogen and carbon. Since we have 5 molecules of hydrogen, so 5 times the enthalpy of hydrogen, this one, negative 286 plus 4 carbons, so 4 times carbon is negative 394. Make sure to draw the correct brackets. Okay, using your calculator, the answer will be positive 129 kilojoule per mole. So it is endothermic, and this is the amount. Do not forget to multiply the number of molecules by the enthalpy formations. This is for the delta H enthalpy. Now, the heat, Q or heat. The law for heat is Q equals M cat. M is the mass of a substance. The substance that we are heating usually is water. C is the specific heat capacity, and it is a given amount. It's constant. Delta T, T final minus T initial. There is no need to convert this to Kelvin. It's okay. The answer will be in kilojoule, not kilojoule per mole, just kilojoule. If you want to convert Q or heat to enthalpy, you just have only to divide the enthalpy by moles. Okay. Now, what is entropy? Entropy means the randomness or disorder. Delta S or entropy is disorder or randomness of products minus randomness or entropy for reactants. They all comes with kilojoule, the unit kilojoule. They will be given to you, but what you should know that randomness increases with increasing the particles. Let's take this example, for example, this one. Look at this. Okay, which one has more randomness or more entropy? The one on the left. It is more disorder, more entropy. Okay, look at the blocks here. Disorder or entropy is the one on the right. Disorder or entropy when delta S has a positive sign, positive, not negative. So in this case, here entropy has a positive sign, and here entropy has a negative sign. We prefer this one, the randomness. Why do we prefer it? We use it in the Gibbs free energy law. Delta G or Gibbs free energy law, it's measuring the free energy in a chemical reaction. So if the reaction, it measures the reaction if it is spontaneous or non-spontaneous. Delta G equals delta H enthalpy minus T temperature in Kelvin times delta S. Delta S is the difference in randomness, delta H the difference in enthalpy. Now we prefer for delta H to have a negative sign and for delta S to have a positive sign. If they are exothermic reaction with high entropy, then the reaction will be spontaneously favorable. Favorable means it doesn't need energy, it doesn't need extra energy from surrounding. So delta G is spontaneous if it has a negative sign and it is preferable. Now, if delta H doesn't have a negative sign, positive, or delta S with a negative sign, if we change the signs of them, then we have to change the temperature, increasing or decreasing, and delta G will have a positive sign. Positive sign means not spontaneous, so it needs an extra amount of energy from outside.